Welcome back to my channel, everyone. Sweet Tips here. What I have here is a bag full of gold filled material that I've already sorted and cleaned. This gold filled material is some of the richest material that I work with. It'll yield about 2 or 3%, which means you'll get 2 or 3 grams of pure gold out of every 100 grams of material that you have. This particular bracelet is labeled 1/10 14K gold. With these numbers, I can easily calculate how much gold I can expect to recover from this bangle. We've got 29.8 grams. We multiply that times 0.583 because that's how much gold percentage is in 14K. Then we multiply this number by the 10th times 0.1, and we can expect to cover 1.7 grams of pure gold from this gold filled bangle bracelet. Here's another piece. It's marked 1/20th 12K GF. This piece says 10K gold filled. This is a watch back from a small pocket watch. It just says gold filled. And this piece says 20 years 14K, which means this has got a thick coating of karat gold over brass. It is gold filled. The 20 years means that you can pull it in and out of your pocket for 20 years before the gold covering will wear off down to the brass base metal. Okay, you got to kind of be careful when testing some of this stuff because the gold filled material will pass the acid test for karat gold because it is karat gold over brass. So if you look right there, that's a valid acid test that would lead one to believe that this is karat gold, when in fact it's actually gold filled material, as we see right there. I've got 2 bangles here. This one's the gold filled bangle, this one is gold plated, and if you notice here, if you put the acid directly on the piece, the gold filled one will resist the acid, but the gold plated one, if you look, it will immediately begin attacking the gold plating and get through to the base metal underneath and start dissolving. So that's one way to test if you're not certain if your piece is gold filled or not. Another test we can do is to file into the metal, and then where we filed right there, just dip that into a little bit of the acid, and you'll see right away it starts turning green right there as it hits the brass underneath the thick coating of karat gold. One other thing before we get started here, it's imperative that we exclude any gold plated stuff from our batch of gold filled scrap. If we put this gold plated stuff in, there's going to be no gold yield because it's just a very thin coating of gold over junk metal. They plate it with copper first and plate it with gold, so we want to exclude this and make sure we check each piece so that we get only gold filled scrap in our batch. In a past video, I made a big deal about excluding magnetic material, but as you can see, these pieces are magnetic. They should go just fine. This is one of the reasons we do the incineration, is to remove any lead that we find in any of our scrap. So far, I've had about 2.5 liters of nitric acid in here. And so what we're going to do now is pour this off. This solution is going to have some silver in it, and a little bit of the gold foils might end up going into this poured off liquid. But you can see the pieces of gold-filled material down in the bottom of the beaker there. Here's the gold-filled material. And what I'm going to do now is continue drawing out the base metals with dilute nitric acid. I'm adding some distilled water here, and now we'll add a charge of nitric acid, about 1/2 liter here maybe. Most of the base metals, not most of them, but a lot of the base metals have now been removed, so we're not as concerned about having a boil over with our nitric additions. I've had the gold foils boiling in dilute nitric now for about 5 hours. These things are looking delicious. Here we go. We're going to try to pour the liquid through this strainer. I've got welder's gloves on. I don't know if this is going to work or not. It looks like it's... Let's try it here. If I don't burn a hole through the strainer, I think we're going to get away with it here. Look at them beautiful gold foils. Alright, what we're going to do now is rinse this out a little bit with some distilled water. I'm going to rinse these foils back into the main beaker. Oh yeah, the solution is looking fairly clear down here now. I think I can pour this off with my gloved hands here. Get the best shot for the camera. That's looking real good, man. Look at them gold foils. They look just gorgeous. Beautiful. I think we're gonna hit this one more time with just a little bit more dilute nitric. The longer we spend here with nitric acid boils, the less trouble we'll have when we do the refining. I'm already seeing a little bit of reaction down in the beaker here. So we probably still got just a touch more base metals that need to be dissolved. And what I'm going to have to do now is filter both of these solutions. I'm not looking forward to filtering these solutions. There was lead in here, and that probably means soft solder, and that probably means tin, and tin is not easy to filter. Tin forms metastatic acid with nitric acid, and it's very thick and will flat plug up a filter paper. So I'm not looking forward to filtering these solutions. I've got a specially prepared filter here that we'll use to capture 100% of the solids from our solution. I've had this filtering now for about 2 hours. Our solution back here has been boiling for that entire time. I'm just going to turn the heat off back here now, and we're going to add some distilled water. Just let this cool off. I've got the first beaker filtered, and here's what we have in the filter. It's purple mud. I'm going to save it and set it aside because we're going to incinerate this later on. It took about 8 hours to pull all of this liquid through this filter. So now what we're going to do is, this solution is going to have nitric, it's going to have silver, and it could have a little bit of gold. And so what I'm going to do is I'm just going to add it to this beaker that's got copper, And we're going to cement any precious metals that's in this solution out onto this copper. Now what we'll do is set this filter back up to filter out the solution from our second beaker. Now we'll move this this beaker that we're cementing the metals out on over here out of the way. Let's pull this one up to the front now. This is day 3 of the refining process. It took another 8 hours to pull this solution through that filter. And just like the last one, what we'll do is we're going to save it now. And we'll incinerate it because that purple mud is going to have gold on it. Now we'll take the filter out of here, or the funnel. Set it back out of the way. I've got some copper in a second beaker here. And what we're going to do is pour this solution into the beaker with the copper. It's going to have excess nitrate, some silver, and possibly some gold. And we're just going to cement it out of this solution on those pieces of copper in there. We're using the copper in this beaker as a sacrificial metal. And what will happen is the copper will dissolve and the precious metals that's in this solution will come out of that solution on the copper and settle down to the bottom of the beaker. This is the first beaker that we filtered. Let's check and see the status of how this is going. Here's our piece of copper that we put in there, and as you can see, there's metal cementing out. It's black, which tells me we've either got gold or some platinum group metals in here. And there's some silver down on the bottom. So the copper is cementing those metals out of this solution. And I found that's the best way to do this. Cementing everything on copper is the best way to go here because you get all the precious metals and then we can just run it through the silver cell. Here's a look at the metals that are cemented out from our waste solution. It's going to be some silver and possibly a little bit of gold and maybe some platinum group metals. It's not a whole lot, but it's worth putting a piece of copper in there and cementing them out. This is a 24 centimeter filter paper, and what I do is I've got an 11 centimeter Buckner funnel, and I just center it up, and then I start going around the edges. This is a 12.5 centimeter funnel, and our filter paper now will fit right down in here and right up the edges of the funnel, and that will make sure that we capture 100% of the solids. Now let's filter off our solids out of this beaker. Here's a quick look at the gold foils that we recovered with those nitric acid boils. It's more or less just thin shells of karat gold that retain the shape of what they used to be. Now this is a good sign. This liquid is pulling through the filter very quickly. So now what we'll do is we're going to gather up these foils into this filter. Yeah, this is pulling through the filter much quicker than the solutions, and I think that's because of the extended nitric acid boils that we did here. So this is looking pretty good. Not sure if you can see that or not, but the solution is a little bit purple colored coming out of the bottom of the funnel. That means we're pulling a little bit of colloidal gold through the filter. This only took about 20 minutes to pull all this liquid through this filter. So now what we're going to do is we're going to remove the filter, get it out of the way. That's our gold foils. That's the valuable gold material that we want. And now this solution in this flask is going to contain a lot of excess nitric acid. I poured the first two solutions in separate beakers and cemented those out with copper. But this is going to have a lot of extra nitric. So what I'm doing, I'll just show you here. I've got some sterling silver pieces in here. I'm going to use up the available nitric from this solution by dissolving those pieces of sterling silver. Any precious metals that are in this solution will be gathered up in this silver jar, and then we'll recover it later on. The recovery process is complete. Here's beaker number 1, waste solution, cementing on copper. Beaker number 2 of waste solution, and if you look in there you can see that we've got some silver floating to the top that's cementing out of that solution on the copper that we've added. And then over here I've got the final nitric solution in there with some sterling silver to consume that excess nitric. And now we're going to turn our attention to the recovered gold foils. See if we can pull this off. I'm going to put these filters in here, and then we're going to try to pull this out carefully without tearing it, and just place it right back into the melt dish. Here's our recovered foils and those filters. What we'll do now is turn our oven on. And we're going to put this in the oven and burn all the combustible material off of the foils before we try to refine it. Very important step here.
Oh yeah. Yeah, that looks good.
Here's our gold foils. They look luscious. And what we'll do now is I've got a stir bar here I'm going to drop it down into the beaker. It's a 2-liter beaker. We're going to carefully get our foils down into the beaker. Now I'll add some hydrochloric acid. Fill it up to about the 400 milliliter level. I'm going to add some heat and start stirring. I've measured out about 50 milliliters of nitric acid. We're going to just add that right on in. I'm going to cover this up now and just let it react. It's been on boiling now for about an hour and a half. I'm going to drop about a half a milliliter of sulfuric acid and add that in slowly to precipitate out any lead that may be present. I'm fairly sure this reaction is complete. Let's take it down off the heat now and let this cool down. I'm adding some ice to help cool it off so we can get a good filtration on this gold bearing solution. I'm going to get set up to do a filtration of our solution now. Got a filter flask with a number 2 medium flow filter in it. Here's what's left in the filter. Those are some plastic beads that did not dissolve. Now what we're going to do is transfer our solution into a beaker. Pour it precipitate out to pure gold. We want to get a stannous test, verify we got gold in solution. That black stain means we've got gold in solution. Here we go. We're going to use some sodium metabisulfite and precipitate the pure gold out of this solution. It's going to be kind of hard to see because the solution is green. The reason it's green is because we've probably got some copper in here. That should do it. Let's get another quick status test here. Make sure we've got all the gold precipitated out of our solution. And as you can see, no more gold in solution. Let me just cover this up and let the gold settle out. It's been allowed to settle for about an hour now. Let's get this green liquid off of here. I'm going to pour it off into a temporary storage container. Gonna rinse it with a little hydrochloric acid. Try to get all that green liquid off of there. Finally got most of the color rinsed out of it. And now what we're going to do, this is the last rinse I'm going to do. You can see we filled this waste bottle up with rinse solutions. I'm going to add some hydrochloric acid here, about 200 milliliters. Add a pinch of sulfuric acid here, just in case any lead made it through this far. I'm adding a stir bar. I will set it up on the hot plate stir here. Commence to stirring and add some heat. Now we're going to add some nitric acid here. That only took about 5 minutes to dissolve. Let's get it down off the heat and let this cool off. Got to transfer some of this liquid into a larger storage container. Make some room. All of this waste solution here goes into my stock pot that's full of copper, and we cement any precious metals, traces of precious metals that's in this liquid. We cement it out on copper in my stock pot. It all goes through a waste treatment process. Let's go ahead and pull this through a filter. Here we go. Here we go. We're going to pour the solution into a clean beaker. It's a little bit touch cloudy, but not bad. I'm going to pour it back through the filter a second time and see if we can get it to clear up a little bit here. Here we go. Let's see if we can pour this back through the same filter a second time and get it to clear up a little bit. I'm glad I did that. As you can see, the solution is much clearer now. I still got a little bit of stuff in it, probably silver chloride. It's a lot better now that I poured it back through that filter a second time. Here we go, second precipitation with sodium metabisulfite. First spoon going in right now. Second spoon of sodium metabisulfite. I don't know if you can see those layers forming right there. This layer in here has got a pink color to it. Phenomenal. Alright, here's one more spoon of our precipitant. One more. And this one should do it for us. Here I've allowed the gold to settle for about 30 minutes. I'm pouring off the waste, and then I'll do multiple hydrochloric acid rinses, followed by multiple distilled water rinses to get all the chemicals off. Then we transfer the gold to a melt dish. A little bit of the water will go over with it. That's quite okay. The flame will evaporate that water before we can have a problem with that melt dish cracking. Let's move it over to the melt table now. Put some flame on it and start this melt. This is a time lapse of the melt. It melted easily, quickly, about 5 minutes, and I could tell how the surface of the molten gold looked, that this was going to be high purity gold and looking real good after the pour. Wow, here is our pure gold bar. Good Lord, it looks just beautiful. Mirror finish. I was expecting 40 grams of pure gold. Let's see what we got down here. 40.3 grams of pure gold. Probably 3/9 fine, or very close to it. I'll offer this for sale on my eBay store. All right, everybody. I appreciate you tuning into my channel. Thanks for watching.